Hello, physics, magnetism, magnetic field. Suppose you have 1 kg of copper and you want to make a solenoid that can produce greatest possible magnetic field for a given voltage. Should you make your copper wire long and thin or short and fat or some other? So there are three options. So first one is wire, long wire, short wire or other. If it is a long wire, then it is a thin cross section. If it is a short wire, then it is a fat cross section or something else. So it's A, B, and C. So we have to find this one. So B, magnetic field in a solenoid is mu naught, permittivity of the magnetic field, permeability of the magnetic field, I, and the turn of the solenoid, and length of the solenoid. So I V is equal to IR Ohm's law. So I is equal to V over R. V is fixed, so that's a value of this one. So B is equal to mu naught V over L solenoid into uh, over R into N. R is the resistance. So R is equal to rho, density of the resistivity, into length of the copper into area of the copper cross section. So if you substitute this value here, then the magnetic field B is equal to mu naught V naught is fixed, into L solenoid into R resistivity, L of the copper over area of the copper into N. This will go on the top. So this will be equal to B. Magnetic field strength is equal to permeability into V naught, L solenoid, resistivity, and L copper into A of area of the copper into N. Area of the copper, this one. So mass is equal to density of the copper, mass density of the copper into volume. And this is equal to mass density of the copper into length of the copper into cross section of the copper. So from here, A of copper is equal to this and this. Mass divided by density of the copper into L of copper. We substitute this value here. So this B is equal to mu naught V naught L solenoid resistivity R L copper into this one. This one is M into density of the copper L copper into N. This one, this is constant, this is constant, this is constant, this is constant, and this is constant. These three is L squared. Now N is equal to number of turn is equal to the length of the copper divided by 2 pi r length circumference of the solenoid. Let's substitute this value here. Then B is equal to mu naught V naught into M into R into copper into L square, L copper into L copper into L solenoid into N, and is L copper divided by 2 pi R solenoid. This cancel. Now this is equal to mu naught V naught M over resistivity density, mass density into 1 over copper, L solenoid length into this is 2 pi into R solenoid. This is constant. So B is proportional to 1 over L copper, L solenoid, R solenoid. So B is greatest when the length of the copper is smallest. So short. So short length, fat wire of copper. And solenoid length should be small. Or solenoid should be small. But this is the answer. So over answer B. So this is the answer of the question, that the for solenoid we have to use a thick copper wire.